Hello, this is Mr. Huber. In this lesson, we're going to look at polygons in the coordinate plane. We've been dealing with lots of different polygons, and particularly quadrilaterals, and now we're going to see how we can work with those where we have coordinates and we're working in an XY coordinate plane. Before we do that, let's talk about distance, midpoint, and slope. You want to recall those formulas. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Or we've seen as well we can use the Pythagorean theorem and set up right triangles. We'll talk about that when we do some examples there where we can use distance that way. Then the midpoint formula, midpoint is where you would add your x coordinates together and divide by 2, and then add your y coordinates together and divide by 2, and that's how you'd get the midpoint of 2 points. It's still an x comma y. And then slope is where you subtract your y coordinates over the difference of your x coordinates, rise over run. Okay, so keep those in mind. We're going to be using those quite a bit as we go forward here with these examples. In this first example, we want to determine if the triangle is scalene, isosceles, or equilateral, and then also determine if it's a right triangle. So this is where we're going to need to use the lengths of the sides and the slopes of the sides to help us figure this out. So let's talk about side AB first. Okay, side AB, okay, has a distance, okay, where we can set up a right triangle. Okay, you can use the distance formula, or if you use this right triangle here, you got the length of one side down here, like on the bottom, will have a length of 6, and the length vertically up and down there would be a distance of 11. You could count it or just go the x-coordinates, you're going from left to right from 2 to 8, that's a distance of 6. Okay, and then up and down you're going coordinates from -5 y coordinate to 6, that's a distance of 11. Again, or count, you're going to have 6 and 11. So then that side AB is, you could do a squared plus b squared, 6 squared plus 11 squared, and you have to square root all that. So if you use the Pythagorean theorem, okay, you're going to come up with the square root of 157. And we can just leave it like that, okay? That's for AB. So we may want to even indicate here that this is side AB. AB has a length of square root of 157 and has a slope of rise 11, run 6. Okay, so that's where setting up that Pythagorean theorem and the right triangle can help as well. You've already counted the rise and the run. It should be pretty straightforward. Then let's talk about side BC over here. Okay. So BC is going to have a right triangle there, where BC is now the hypotenuse of this right triangle with lengths of 7 and 6 for the legs. Okay. So we're going to have the square root of 7 squared plus 6 squared. Okay. That's a square root of 85. And that will have a slope, okay, of rise 6, run 7. Negative, because we're going down 6. When we talk about the slope, we have to make sure we pay attention to whether we're having positive or negative numbers there. With the distance, it wouldn't matter because we're squaring it. So you can put it as -6 squared, so it's still going to come out to 36 when you're finding the distance or using the Pythagorean theorem there. And then if we talk about side AC, okay, side AC, again, if I set up a right triangle, and I've got a length of one side of 5 and another side of 13, then AC is the square root of 5 squared plus 13 squared. And that's going to be a square root of 194. And it will have a slope of rise 5, run 13, positive. Okay. So we want to look, first of all, is it scalene, isosceles, or equilateral? That determines by the lengths of the sides. All three of these sides are different lengths, so it's going to be a scalene triangle. Okay. If two of the sides were the same length, it would be isosceles. If all three are the same length, it would be equilateral. And then, is it a right triangle? So that's where we use the slopes. Where for two sides, two segments to be perpendicular, their slopes have to be opposite reciprocals. So opposite signs and reciprocals. None of these slopes are opposite reciprocals. Okay? We have 11 over 6 and negative 6 over 7. Those are fairly close, but they're still not exact opposite reciprocals. If we had 11 over 6 and negative 6 over 11, then we'd have two lines that were perpendicular to each other. Since none of these lines are perpendicular, is it a right triangle? No. So we have a scalene triangle that's not a right triangle. Again, using the distance and the slopes to help us figure those two pieces of information out. Okay. Take a look at another way we can use this here. Right? We've got 4 points, and we would want to determine the most precise name for the quadrilateral. So one good thing to do to start out here would be to graph it. Okay, so draw myself a graph, and we're going to go to negative 3, 2. That'll be a point right there. That's point A. And we can label it as well as negative 3, 2. Then we got point B at negative 2, 3, 4, 5, 6. Negative 2, 6, right about there. Then we got point C at 1, 3. That's point C at 1, 3. And point D is at 2, 7. And we could draw in then the sides. And so we've got a little bit of a sketch there of this particular quadrilateral. And we're going to determine the most precise name. So we've seen where we can do that by using the lengths of the sides, right, to find out if they're congruent or not. We want to find out if sides are parallel or not. That's where we're going to use slopes again. So we want to figure out the lengths of the sides and the slopes of the sides. So let's just start here with side AC. Okay. Side AC has a slope of rise 1, run 4. Okay. And as a distance of, we could set up the right triangle. Okay, we could set up that right triangle there with side lengths of 1 and 4. So it's going to be the square root of 1 squared plus 4 squared. This is going to be the square root of 17. So that's for side AC. Okay. Let's talk about side DC. Okay, DC has a slope of, we're going to rise 4 and run 1. So a slope of 4. And it has a length of the square root of 4 squared, which is 16, plus 1 squared, which is 1. That's a square root of 17. That's for side DC. Then let's take side BD. Okay, BD has a slope of 1 over 4. We're rising 1 from 6 to 7 and running 4 from negative 2 to 2. Or you can count rise and run on there. Or you can use the slope formula. Do y2 minus y1 over x2 minus x1. That's fine as well. You should get the same answer of 1/4. And it will have a distance of the square root of 1 squared plus 4 squared. So that's the square root of 17. And then finally, side AB will have a slope of rise 4 and run 1. So that's a slope of 4. And a distance of the square root of 17. Okay, 1 squared plus 4 squared. Again, is square root of 17. So you can see that all 4 of these sides are congruent. They've all got slopes of 17, or excuse me, square root of 17, square root of 17, square root of 17, square root of 17. So all 4 of those sides have a length of the square root of 17. So all 4 sides are congruent. Then let's look at the slopes. Okay, the slope of side AC is 1/4. That's this line right here, AC. Across from it is side BD, has a slope of 1/4. So these two sides are parallel. All right, they both have the same slope, 1/4 and 1/4. And then we look at side DC, has a slope of 4. That's right here. And the side opposite that, AB, has a slope of 4. So these two sides are parallel. So we have opposite sides parallel and all four sides congruent. We don't know what type of figure that is. It's a rhombus. All right? So it's going to be a rhombus. You also could use the diagonals, okay, if you wanted to figure out BC and AD, you could figure out their slopes and see that they're perpendicular to each other. And so then if you found all four sides are congruent, okay, and the diagonals are perpendicular to each other, that would be a rhombus or a square, right? We'd have to know then we don't have right angles, so it would have to be a rhombus. Okay, that's another thing to look at here, right? All four sides congruent could be a square, but we know that these are not right angles because these two lines BD and DC don't have slopes that are opposite reciprocals. They're 4 and 1/4. It was 4 and negative 1/4. Okay, then maybe we'd have a square. So look at those, make sure you don't have right angles as well. Okay, so we have a rhombus in this particular case. Most precise name we can give based on the information we have. Draw it out, use distance, use slope for sides, diagonals possibly, to determine what type of figure you have. All right, let's take a little break here for did you know what year the first Rose Bowl game was played? What year was the first Rose Bowl game played? Okay, for answer, here's a picture from back January 1st, 1902, the first tournament East-West football game. That's what it was initially called that first time. Michigan traveled out to California to take on Stanford and beat Stanford 49-0. Stanford actually quit in the middle of the third quarter. They were getting beat so badly. Fielding Yost's teams back then at Michigan were quite dominant. They went 11-0 that year and won a national championship. The football game was actually started as a way to help fund the Tournament of Roses parade that they held annually. So they wanted to have a football game to help generate some money to help offset the cost of the parade. But since that first game was so lopsided, they actually canceled playing the game until 1916. In its place, they had ostrich races and chariot races and other things to help generate money. And in 1916, they started playing the game again and actually called it the Rose Bowl at that time. And it was actually played at a place called Pasadena Park until 1923 when they built what is now the current stadium, the Rose Bowl that you see there. So the first Rose Bowl game, 1902, Michigan beating Stanford 49-0. Let's look at one more example here. Okay, what I'd like you to do is pause the video, try this problem out on your own, then press play and see how you did. Okay, now you've had a chance to try this problem on your own. Let's go through it and see how you did. Okay, so again, I would suggest graphing would be a good way to start. So we go, this first point is at -5, -4. That'd be point R. Okay. Then point S would be at 3, 1. All right, then we have point E at 1, -2, right there. And we have point O at -3, 0. And if we draw in the sides, okay, we've got a quadrilateral. We got to figure out what might be going on here. So let's find the distance and the midpoints, or excuse me, the slopes. The distance of this side SE is the square root of 13 and has a slope of 3/2. Side OS has a slope of 1/6 and a distance then of square root of 37. Remember, set up, count the rise and run. That's like setting up your right triangle, the Pythagorean theorem there. If the rise is 1 and the run is 6, the distance is square root of 1 over square root of 6. Or excuse me, square root of 1 plus a square root of 6, square root of 37. Okay? And then side RE down here would have a slope of 2/6, which we could reduce to 1/3, and the distance of square root of 40. And then side RO would have a slope of 4/2, which is 2, and a distance then of square root of 20. So we don't have any parallel sides, any perpendicular sides. We have no congruent sides, right? They all have different distances, different lengths. We look at the slopes, none of them are the same, none of them are opposite reciprocals. So in this case, we just have a quadrilateral. No other more specific name we can give. It's just a quadrilateral. Okay, again, using slope, using distance to help figure out where we have sides that are congruent, parallel, perpendicular, to help us figure out what it might fit into, what category it might fit into. If we can, name it something like a square, a rhombus, a rectangle, a kite, a trapezoid, whatever the case might be. All right? So remember distance, remember slope, use those pieces of information. Again, diagonals can be important as well to figure out if you have diagonals that are perpendicular. That can help you determine some things about what type of quadrilateral you have. So use those pieces of information to figure out where you have congruency and parallel and perpendicular sides of your figures, whether it be triangles or quadrilaterals.